everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Iñigo, who has just completed the course Linux Basics for Robotics, and he will be giving us a presentation of that. So without any further ado, let me hand over the platform to him so he can begin his presentation. Alright, whenever you're ready.
So, one second. I have a problem that I don't see the screen of the robot simulation, of the real robot.
You do not have the camera feed. Okay. Go on the button next to that on the left.
This one?
No, the one on the left.
This one.
With the antenna. Yeah. With the antenna.
Okay, this one. Okay.
Yep, that one. Yes.
Perfect. Thank you. So, I start with the presentation. I'll prepare here a little presentation.
Alright.
So I will be doing the presentation for the Linux Basics for Robotics. And these projects consist of 3 parts. The first part is to get to know the robot and the lab. The second part consists of creating a program to control the robot. And the last part is the implementation of a basic robot algorithm. So I will start explaining with the first part. The first part, as I said, is to get to know the robot and the lab. In this case, I will be using the TouchBot, and this is the simulation scenario that I will be working on, and this is the real scenario for the real robot. So to get to know the robot, they told us in the documentation that we need to teleoperate this robot, and we can do it in 2 different ways. The first one is in a simulation. So we need to launch the simulation. So using this two line codes, we can start a simulation in Gazebo. That is this one on the top. And we see something like that. And after that, we can teleoperate this robot, the TouchBot, using the next command line on the terminal. And instead of doing this in a simulation, if we want to do it like in the real world, we just need to start like to visualize the robot in the laboratory, and after that we need to just use the next command line to teleoperate the robot, and with the keyboard we just can move the robot like up, down, and turn around and everything.
Alright.
Okay. After that, we just complete the first part, and we need to do the second part. That will be creating a program to control the robot. In this part, the documentation says that we need to create a ROS2 packets to control for robot controlling using the terminal. And after that, we need to create a bus file that contains a list of functions that will be using in the next part of this project. So to create the packets, first of all, we need to be inside of our workspace, that is this one, ROS2 workspace, and then go to the directory called src, and inside that directory we create the packets using the next code line in the terminal that says how we build this packet, and then describes the dependencies that we'll be using, that are these ones. And after creating our packets, in the documentation they tell us to do some tasks that are going to be to navigate inside these packets using the cd commands. Then they told us to remove the directory name test, to open the package, a file named package.xm, and to remove the next following lines inside this file.
Alright. You must also make sure that you need to show the demonstration on the real robot. So do your presentation a lot quicker so that you keep the time allocated for you in check. Okay.
Okay, perfect. I will. Yeah.
Alright.
And after that, they told us to modify the descriptions and the maintainer fields in this file. And then it tells us to move 2 files from this path to this path inside the package that are going to be robot interface.py and simplepatrol.bas. That if we look to our workspace, it would look something like that. We have here the workspace, the file src, and then the package with these files inside of it. And then it also has to provide executable permissions with chmod. Then we put +x, and then we tell the files that we want to give the permissions that are going to be robot interface and simplepatrol. So after that, they told us to execute the simplepatrol program. So we go to the directions where we have the 2 files in 2 different terminals. First, we execute these programs, and after that, we are able to execute the simplepatrol bus file, and we will see that the robot will do like a simple. It would be moving around the scenario, doing like a patrol.
Okay.
And then the last task we need to do in the part 2 is to create a bus file named robot functions, and we will provide it with executable permissions, and we need to create some getters and setters functions that they told us in the documentation. For example, I put some getters functions. These are 3, but they told us to do much more. And yep. And the last part is to implement a basic robot algorithm. So we need to create a new bus file named obstacle avoider. Then using the ID, we will be writing our program that will need to include a cback line, that's this one. Then include the robot function file. So we will use this line in our program. And finally, we need to follow the pseudocode explained in the documentation to create this basic algorithm. And after that, they told us to create another bash script file that is going to be robotstatics.bash, this one. And this bash file, when we execute it, it will show some statistics of the robot, like how much distance it has been doing and all that. So to create this bash script, the algorithm, we need to follow as well the pseudocode that says in the presentation.
Okay.
And that's it. That's the presentation that I prepared. And now we will watch how each part of the project that I will be doing. So the first one is tells us to operate the robot in the first part. So first of all, we need to get these 2. So in our terminal, we will launch these 2 code lines, and with that, okay, sorry, this is for the simulation, but it's good because with that we can see the RPs. That is how the sensors on the robots are getting information. That is this one, so it's interesting to see. And then in this terminal, I will use to be ROS2.
You should be able to use RVs without having to learn simulation, but okay, you can go ahead.
Okay, I don't know that. Develop trees, keyboard, and Cilio. With this we can just operate the robots with the keyboard. So for example, my robot is here. So pressing the key I can go forward. I'm using this keyboard here. I can go forward, turn right, left, everything. Move the road around my scenario. So this will be the first part of the ROS project.
So
I think finishing,
I think it would be ideal that you close the RFS window at the moment, because I don't think it's showing the correct values. So.
Okay. And after that, the second part will be to execute the simple patrol program.
Script. Okay. Can you maximize your camera window so we can see the robot in more detail?
This one.
Yep.
Wait.
Or maybe just drag it so that it's a little longer. Okay.
So I need to go to ROS2, and inside that I need to go to the directory src. After that, to the Linux Access project package. And inside here I got these files. So here, first of all, I need to run this robot interface.py.
Yes.
So I will be able to execute the simple patrol program. And after that, in another terminal, I do the same, but instead of executing the robot interface program or file, I will be executing the simple patrol.
Okay.
So this will be this, and this. So here I need to do that simple patrol bots, and it will be executing a simple patrol program, so that the robot will be moving around the scenario doing patrol.
Okay.
And this will be the second part of the program. So as we can see, we'll be moving a little bit forward, moving around, doing a patrol. And after that, the last part of the...
We'd like to see if it manages to avoid an obstacle at some point, right? So you stopped it
Okay. Sometimes I'm like really fast.
Yeah, it's alright. I think you still have got some time. So 14 minutes or so. So that should be okay.
So as we see here, it has some obstacles. So the robot will be like setting the parameters, going forward, moving around, and here has like a little sensor that records the distance from the objects around to the robot. So we set the program sets like a minimum distance, so that the robot will not just crash into the object.
Okay.
So we detect, yes. After detecting like this distance, it would try to go like the opposite way. Let me see if it's going forward. It's moving forward. And here it detects the distance. Did it crash? Yeah.
Did it crash? Yeah, it seems like it's too close to the wall now. Okay. You can use tail up to bring it back a little, and then we try another run.
Yep. This one was too low. No. Okay, this was the simulation.
We don't need simulation, so yeah.
Run, cheer up. Well, I want to clean this. Clear, run. What? Sorry, ROS2, run, cheer up. These keyboards. Clear up. These keyboards. So backwards, I think is with an M. Yep.
Yeah.
Maybe we turn it around. More or less.
No, you can use J or K or L to rotate in place.
What?
Yeah.
I was using U, but I think U is not. Sorry. Okay, maybe so. Yeah, it was out. Okay, I think there is fine. Yep. After doing the simple patrol, just the last part that will be in the ID. Sorry, it's not this one. This one. Okay. In here, the last part says to create these two bus files. That is the obstacle avoider. That we have been doing like using the simple patrol bus. Well, wait. Yeah, using the simple patrol bus file, like taking a look to this one, how it's created. I create like this one, the obstacle avoider bus files, that makes like a simple patrol as well, with different options following the shadow code that says here in the notebook. Like in this last part, they gave us this shadow code.
Okay.
So it says set the velocity to 0. So we need to the command in the bus file to set the velocity to 0. That is set cm linear velocity equals to 0, and following this shadow code. So we will see if it works properly. So first of all, we need to execute the robot interface. Then here I need to execute the obstacle avoider file. And finally, like in a new terminal as well, the road statistics file, ROS2 src, Linux, and here under robot statistics plus. I will tell us like the current direction that's moving and the distance that it has moved. And its position. So here we will see that the robot is like moving. Set is looking for obstacles. I think that I set the distance like really too big, so that's why the robot is turning around, because in the simulation like 0.5 it was 0.5. Let me see.
It crashed again.
Is the threshold. I put 0.5.
Okay,
so I just set it like lower.
Okay, so the script that you're running is obstacle avoidance, right?
Yeah.
And at this moment, it chose the wrong direction. So can you try expand it, run it in a different place, so move it to a different corner, and let's see if it manages to avoid obstacles there.
Okay. Let me try.
And you were speaking about using a threshold value of 0.5. Did you try 0.3 and it didn't work? What's going on there?
I changed it to 0.3 because when I was looking to this terminal, it says the right range, the front right range, the front is set like all the distance. At the beginning, every like range was like front one was like really close, like lower than 0.5, So that's why the road was starting to turn around itself.
Okay, all right. So let's see how it works right now, because I think the front is quite clear. So
okay. So first this one. After that, this one. I think that this one should be working. Yep.
okay, moving forward. That's good. Turning right. Okay, that's good. Okay. It's still struggling a little bit to figure out which direction to go, and
yeah,
okay.
And this is because this stops. Let me try to see one thing.
I think you're gonna run out of time soon, but anyway, it's alright.
Yeah, I did. Yeah, I did run out of time.
Alright, so can you run us through what's going on in the obstacle avoidable bash, right? Because we want to understand why is it sometimes figuring out the right way of avoiding obstacles, and why is it failing some other times.
Okay. So first of all, we need to, like, when we run this code, the first thing we do is to set the linear velocity, angular velocity to 0.
Yep.
And set a threshold. The threshold is the distance that our robot is going to say, okay, so if I am closer to an object at 0.2, I will stop and I will do another action.
Yeah, don't you think 0.2 is too close though?
Yeah, maybe that was the reason.
Yeah, but it's alright. We are here for discussion and we are trying to understand what happened. So yeah, let's go on.
After that, we have a loop here that from the sensors, from the scan, we get the right range, the front right, the front range, the front left, and the left range. So from the sensors of the robot, we take like 5 different directions that are on front, on the right and left sides. And here I set some initial values that if for left, if it is free, like the robot has enough space to go, this will be set as 1. And if there is no enough space to go, like to the right, to the left, or to the front, this will be set as 0. So here I do a check of the distance. So if the right length range is lower than the threshold, I would say, okay, I don't have enough space to go to the left, so I will set this to 0.
Yes.
And I do this the same to the with the front variable and the right variable. After doing that, we are going to see 8 different cases. The first one is if the front and left are not free, but and if front is if left is not free, front is not free, and right is not free, like the robot cannot move anywhere, I need to see which direction has more space to go.
Yeah. So okay, let's try to understand what's going on in that sector. So if you're saying if front is not free, and if front left is not free, and then if front right is not free, right? What happens after that? Does it rotate?
So I need
it
to
just
see
stops?
in which one I have more space, so I can rotate to one direction or to the other direction, just to not crash to with an obstacle.
Okay, so within that loop, you have another loop that also checks, like, after considering that everything is not free, you're still trying to check which one has got the furthest distance.
Yeah, because I need to like turn around So to do that turn, I need to see if I have like enough space, or in which one I have more space to do that turn.
Yeah, I feel like this is tying you down. This is tying your robot down to not be able to make a decision properly. But anyway, just food for thought, because you did notice that when it got stuck, it kept on rotating, right? So I'm thinking it's probably because of this. And there is, once you get into that loop where the front left, front right, and front cannot be considered to be free, then the robot keeps rotating and not making a decision, right? Or whatever decision it makes, it will be less optimal because your threshold values is already the value that it's getting is already under 0.3 or 0.2. I think this might be the one that's causing it to crash, but
okay,
it's a learning curve. So okay, let's go on.
Then here I look for the 3 different cases. If the right is free, then turn right. If front is free, just move a distance to the front. The distance to move is going to be calculated by the range minus the threshold. And with that, we calculate the time to move, setting a velocity of 0.1 meters per second. And we move it to way forward, and then we stop it.
All right.
And then the other.
Yeah, unfortunately we are out of time, but yep, thank you very much for your presentation, Iñigo. So you just hang around and then we wrap it up here, okay?
Okay, perfect.
Alright everyone, so this was Iñigo's presentation, and I would like to thank him for giving the courage to come and showcase his work. And to all those of you who would like to try this course, you're welcome to do so, and then you can come and also make your presentation. So until next time, keep pushing your ROS learning. Bye bye.